Here is a quick presentation on how to use sulfonate esters to convert a poor living group into a good living group. So let's consider this example in which we want to react this organic alcohol with carboxylic acid. Now, if we try to perform this reaction, what will we get? We will get nothing. This reaction is not going to proceed. We have to do something. We have to make this OH group, which is a poor living group, into a good one. How do we do that? And this is where we use tosylates. So this is basically the same reaction. We have our organic alcohol, we have our carboxylic acid here, but we have also a tosylate. This reaction yields our final product, in which we wanted to make this OH group leave and to make a bond with our R group here. And we have a tosylate attached to the oxygen. Now let's look at this reaction step by step. Here, again, our organic alcohol, and this is a chlorine tosylate. Now this reaction basically results in our organic molecule being reacted with tosylate, and we get basically the tosylate here as now a leaving group that is attached to our organic molecule. Now this is a good leaving group. Okay, so this is what we're looking for. And as a reaction product, we have proton and chlorine, which is hydrogen chloride as a byproduct. So now that we have our organic molecule with a good leaving group, we can actually have our initial reaction to actually occur. So remember we were trying ROH plus OC double bond O CH3, and this was not happening. Now, because it wasn't happening because the OH group was not leaving. So now, instead of our OH group, we have this, a very good leaving group. Anyways, so what happens here is that we have our R group now easily interacting with the carboxylic acid, and we get our R group reacted with our carboxylic acid. And our product, the second product, is our O tosylate minus. Tosylate O minus. So this is the second step of the reaction. Now let's look at it a little more general. Now here is another organic alcohol. Now we have a benzene ring here and alcohol. That's for practical purposes compared to the previous example. This is the R group. Anyway, so let's say we want to have this reaction and we want to get a product which, let's say, is something like this, a benzene ring with, I don't know, let's say a nucleophile, any nucleophile, okay? Anything that we want to react it with. In previous case, it was the carboxylic acid. Just to keep it simple, let's call it um, our nucleophile. So let's go step by step and see what's happening here. We have the molecule, and we reacted with chlorine tosylate, right? Okay, so what's happening here? The first step here is that we have 4 electrons here, right? With hydrogen, with oxygen. What we have here is we have this attack right here. Okay, and of course this liberates an electron that chlorine readily accepts. Okay, so we get something like this as a product. We get something like this. Our benzene ring here. Now attached to oxygen, this is this oxygen right here, its own oxygen, and which is now attached to S, double bond O, benzene ring, CH3. Okay, so from this point on, it's fairly straightforward because this is a very good, very good leaving group, right? As we said. So if we have a if we have our compound in this, let's say let me just call it TS for simplicity. Now, if we have our nucleophile here, right? Our nucleophile will very easily attack this carbon right here, releasing this electron to the oxygen. And as a product, final product, we get a benzene ring attached to our nucleophile plus, remember this oxygen took up 1 electron, so it's O minus that is attached to our top. So in conclusion, when we have tosylates that are reacted with our compound of interest to make it into a good leaving group, we basically ended up with our compound of interest, oxygen, S double bond O, hexane ring, CH3, right? This is tosylate. But of course, this tosylate is not the only molecule that can perform magic, let's say, like this. Other molecules such as hydrobromic acid can do such substitutions also. But in terms of tosylate-like molecules, there is another one called Tosylate. Can you guess what it looks like? Well, reacted with our R, it would look something like this. Bromine. So this would be the Brussels group right here, and this would be the Tosylate. And the chemistry of this is just like that of tosylate. So this is it. I hope this helps. If you have any questions, please let me know. Thank you.